Okay, so now we're going to do a practice problem. In this example, a friend tosses you a softball with mass m ball with a velocity of v ball initially in the x direction. You swing a bat with mass m bat, and just before the impact, the bat has a linear velocity of v bat initially in the negative x direction. After the collision with the bat, the ball has a new velocity of v ball final in the negative x direction. Assume this collision is inelastic. So for part A, we're going to find the ball's impulse. And for part B, we're going to find the velocity of the bat after the collision. Okay, so for part A, we can say that impulse I is equal to delta rho, change in momentum. Change in momentum is equal to the mass of the ball times the final velocity of the ball minus the mass of the ball times the velocity of the ball initially. Since the mass remains the same, we can simplify this to saying mass of the ball times, in parentheses, the velocity of the ball finally minus the velocity of the ball initially. This is our impulse. For part B, we know that there are no external forces acting on our system, and we know that this is an inelastic collision. Thus, we can say that momentum, or delta rho, is zero. Momentum is conserved. So we know that the momentum of the system initially is equal to the momentum of the system finally. Using this, we can say that the mass of the ball times the velocity of the ball initially plus the mass of the bat times the velocity of the bat initially is equal to the mass of the ball times the velocity of the ball finally plus the mass of the bat times the velocity of the bat finally. Now we have an equation where we can solve for the final velocity of the bat. To do this, we just move one term to the other side and divide by the mass of the bat. This gives us the final velocity of the bat after the collision.